With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply states you are given two concentric charge conducting sphere of radii r1 and r2 such that r1 is greater than r2 and having charges q1 and q2 respectively. So here you can see that this is a conducting sphere. It has charge q1 uniformly distributed over its surface. Now remember one thing before solving the problem. Since the spheres are conducting, so all the charge will simply remains on the surface because the charge cannot exist inside a conductor, right? So the charge will exist only on the surface. And you can see here this is R1 because R1 is simply greater than R2. So the outer sphere which has Q1 charge has simply radius R1. Now what we have to calculate? We have to calculate electric field and potential at 3 point A, B, C. So we have 3 point. One is A, that is outside both the spheres. Other is simply B, which is simply here in between these two spheres. And the third is simply inside this sphere. Then we have to find electric field and potential. So let us try to find out electric field and potential one by one at all the points. Let us first try to find out at the point A. At point A. So the electric field at point A will be due to this sphere, right? And due to this sphere. Now when we find the electric field at any point outside the sphere, so what we assume is that the entire charge is simply placed at the center and we treat that as point charge. So let us try to find out electric field at point A. This will be simply 1 upon 4 pi epsilon naught. First you see that this entire charge on this sphere Q1 will be assumed to place at the center, and you can see that then this will act as a point charge which is placed at the center and the distance is simply RA. So the electric field due to the larger space is simply Q1 divided by RA square plus the electric field due to this charge. Now again with the similar concept we will treat this all charge to be placed at the center, and you can see that we have to find electric field at this point. So this will be 1 upon 4 pi epsilon naught Q2 divided by RA square. This will be the magnitude of electric field Newton per Coulomb. Now we can find out the potential by applying the same concepts. Now you can see it. So VA potential at this point will be due to this sphere, and again we will assume the entire charge to be placed at the center. So this will be 1 upon 4 pi epsilon naught Q1 is the charge on this divided by RA plus similarly 1 upon 4 pi epsilon naught Q2 divided by RA volts. So this is about the point A. Now let us try to find at the point B. So let us try to find at point B. Now the point B is inside this conductor. So the electric field at B will be simply due to this conductor. Why? Because inside a conductor electric field never exists. So the electric field at point B, if we find the electric field at point B, this will be simply 0 due to this sphere plus, now again we apply the similar concept that we treat that this entire charge is placed at the center and this distance is RB. So this is 1 upon 4 pi epsilon naught. Now the total charge is simply Q2 and it is placed at a distance of RB. So that will be RB square. So this Newton per Coulomb is the electric field. Let us now try to find out the potential at point B. So how do we find the potential? Now the potential is not 0 due to this sphere. So the potential due to any charge sphere inside any point, right? So you can see this B point is inside this sphere. So the potential at B will be due to the first sphere and it will be given by 1 upon 4 pi epsilon naught Q1 divided by R1, because the potential at any point inside this sphere due to the charge on this sphere is simply this. Now let us try to find out the potential due to this sphere. Since this point is outside, so we can write 1 upon 4 pi epsilon naught Q2 divided by RB, because for this sphere this point is outside. Now let us try to calculate, this will be in volts. Now let us try to calculate at point C. At C, now the electric field is 0. Why? Because the point C is inside this sphere. So at C the electric field is simply 0. And what will be the potential? Potential will be the sum of potential due to this sphere and this sphere. So the potential at C will be simply 1 upon 4 pi epsilon naught. So you can see that the charge on this sphere is Q1 divided by R1. This is the potential due to this sphere at any point inside this sphere. Now similarly we can write for the smaller sphere, this will be 1 upon 4 pi epsilon naught Q2 divided by R2 volts. So this will be the final answer. I hope you understood the entire explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.